Good morning, everyone. Today is February 12th. So we will continue to talk about sessions 8.1. And this week, you don't have any homework or quiz. Just continue to work on your homework 7.1, 7.2, and 7.3, and 7.4 so that you get all perfect scores. Even though after the deadline, you can still work on your homework to improve your scores, right? So I hope everybody can get perfect scores on your homework. And exam. When is our exam? Monday, next Monday in class. And I will be here like 8:50, so you can come early to start the exam early. And after the class, I'm teaching applied calculus 2 after our class. So if you need some extra time, feel free to stay and continue to work on your exam. Okay? So I hope time is not an issue for you. And on our course website, there is a practice exam and the solution. Okay? So I want to give you a feeling what's gonna like in the actual exam. So the practice exam and the actual exams, they have like similar type of problems. So this is the practice exams, and this is the solution. So you first finish the practice exam using pencil, and after you finish, use red pen to look at the solution. And please check the steps, okay? Because every step has points. Like this problem, I give you 7 points, and you're not supposed to plug in your calculator and just give me a number. No, okay? I want exact value and show all your work. What do I need? I need to draw the picture, tell me what the reference angle, and then express that trig function, find that values using the reference angle. And also we have 2 trig functions here, so find them and then multiply them together. So when you look at the solution, check the detail. Is that clear, everybody? If you only give me a number instead of all the work, you might only get like 1 or 2 points out of 7 points. Is that clear, everybody? So please look at the solution carefully. This is not like your homework. You just enter the number. You have to show all your work, okay? So that's the practice exam. After you finish, write down the scores in each problem and then add them up to get the total score. Because after you take the actual exam, I will give you exam reflection survey, and then I want you to compare the practice exam score and the actual exam scores. So I don't mind you get very low scores on the practice exam. We know our weakness, so we can improve, right? So some of my students tell me that they did the practice exam 3 times. The first time is 1 week before the exam. The second time, 2 days before the exam. And the last time, the night before the exams to make sure they remember all the methods. Okay, so I strongly recommend you to do more. And please be honest when you solve the problems. Don't look at the solution. Once you look at the solution, use red pen. Okay? Don't use pencil. Okay, so yeah. So today we're gonna continue on sessions 8.1. And last Friday, you have questions?
Yeah, will we do a review session?
No.
Like at night or something?
No, not for this course. Yeah. Okay. All right. So let's see here. Okay. Right. So this is the Friday. If you missed the class on Friday, I hope you watched the recording. So Friday we went over the chapter 7, the blank notes, and today at the end of the class, you're gonna fill in the sheets. Okay, so I will give you this blank sheets so you can fill those in at the end of the class. Again, this is not for grade, but if you don't get them perfect, I will ask you to come to my office and do it again and again. I really want to try my best to help you. Remember the unit circle practice? 8 of you get them all right. So I still need 10 of you. Come to my office and take it. Today, I will be in my office from 11 to 1:50. And tomorrow, I will be in my office from 10 to 1:50. So that's today. That's tomorrow. Okay, so we need both efforts, you and me. Okay, let's try our best. If you didn't get the unit circle perfect, come to my office and take it. Okay. All right. So let's continue. So chapter 8, we learned the graph of the trig functions. Okay. So last time we did the sine function. Okay. The sine function, I told you we focus on the 5 key points. They are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then you remember the y coordinates. They are 0, 1, 0, minus 1, and 0. Those 5 key points. Do you still remember that, everybody? The sine is like the wave, okay? Oscillating up and down between -1 and 1. So today I give you the chapter 8 blank formula sheets. You see this part? You already learned that in chapter 7. That's why the trig identities and this table is very important. So today, let's fill in the sine values. Everybody has this handout? Yes? Jeremy, do you have it? Oh, okay. Okay. So only the 5 key points. They are what? 0 over 2 pi, 3 pi over 2, and 2 pi. How about the y coordinates? 0, 1, 0, -1, 0. Yes. Okay, so this is 0. And so 2 pi is here. Then pi is in the middle. Okay. The period is 2 pi. So let's draw from 0 to 2 pi. And then pi over 2 is in the middle of 0 and pi. Bless you. 3 pi over 2 is in the middle. Bless you. Is between pi and 2 pi. Okay, let's plot the point. It's 0 is 0. At pi over 2, we get 1. And at pi is 0. 3 pi over 2, -1. And 2 pi, 0. So remember those 5 key points. And then we connect them smoothly. So this is one period of the sine function. Thank you. Everybody finished the sine function? So 5 key points. Okay. If you need to go deeper and look at the values, last time I told you that look at the first quadrant if you want to go deeper, right? So important angles, they are 0, pi over 6, pi over 4, pi over 3, and pi over 2, right? That is the first row of your table, okay? You see the angle are increasing, and also the y values are increasing. They are, remember the rule, square root of n over 2. So you have 0. Next, 1/2. Yeah, everybody? Next, root 2 over 2. Next, root 3 over 2. And then next, 1. Everybody remember the first row of our table? Yeah? The first row of our table. Okay, square root of n over 2. This is the pattern. Okay, you use this pattern and then you can fill in the values of the table. So we fill in the values together twice in class, right? Yeah. So at the end of this class, you're gonna fill out those tables. Okay, so let's continue. So that is sine. Let's continue and draw the graph of cosine. So cosine, the special angle, okay, the 5 key points we want to draw are 0, pi over 2, pi, 3 pi over 2, and what? 2 pi. Yes, everybody? Okay, cosine values. This is not only in the first quadrants, so we need to look at the unit circle. Okay, remember the unit circle? The x coordinate is the cosine. The y coordinate is the sine. Last time we looked at the sine. Today we look at the cosine. What's cosine 0? 1. What's cosine pi over 2? 0. Cosine pi? -1. Cosine 3 pi over 2? 0. And cosine 2 pi? 1. Yes, everybody? We have 5 angles. And look at the x coordinates. So they are 1, 0, -1, 0, and 1. So keep that in mind. Write it down. 1, 0, -1, 0, and 1. Yes, everybody? Okay, plot those on the graph. It's 0, but at 1. So that's 1. Put the point there. Pi over 2, 0. At pi, -1. 3 pi over 2, 0. And 2 pi, we get 1. Is that okay, everybody? Those 5 key points. And we connect them smoothly. Okay, so we connect them smoothly, so we get 1 period of the cosine. Yes, everybody finish those 5 key points? Yes? Okay, so look at this picture. This is 1 period. So if you want to draw more periods, you can copy and paste right here. Then you get this picture. Okay, copy and paste. Now you can see the domain or the x can go to infinity, it can go to minus infinity. So the domain is what? All real numbers. So minus infinity to infinity. Or you can say the set of all real numbers. Okay? How about the range? Yes, -1 to 1. So domain is the x values. Range is the y values. The y is between -1 and 1. Is that okay, everybody? All right. And the period is 2 pi. So this is 0 to 2 pi. You can copy and paste. So the period is 2 pi. The graph is continuous over its entire domain. Remember, continuous is you draw the picture without lifting your pencil from the paper, right? So this is continuous. And where are the x-intercepts? You see the x-intercept are pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. Right, everybody? We can summarize. That is to be
So the x-intercept are pi over 2 plus n pi, where n is an integer.
So this is pi over 2. When you add pi, we get 3 pi over 2. When you subtract pi, we get negative pi over 2. When you subtract 2 pi, we get negative 3 pi over 2. So all the x-intercepts, we have infinitely many x-intercepts. They all follow this pattern. It's pi over 2 plus n pi, where n is an integer. It could be positive, it could be negative. Right, everybody?
Okay, and the cosine function is an even function.
Do you see it's symmetric with respect to the y-axis? Can you see that? Again, even function is symmetric with respect to the y-axis. How about our function? Our function is symmetric with respect to the origin. Do you guys remember? Yes? And last time we talked about, last chapter, we talked about the 6 trig functions with negative angles. And we say, what, cosine and secant are so hungry. So they eat the minus sign. And all the other 4 trig functions, sine, cosecant, tangent, cotangent, do they eat the minus sign? No. So those functions are arc function. So sine is arc function. They're symmetric with respect to the origin. And cosine and secant, they are hungry. They eat the minus sign. So they are even function.
Okay, if we go deeper, okay, so focus on the first quadrant. If we go deeper, look at the first quadrant. Okay, and look at your table.
Cosine 0 is 1. Cosine pi over 6
is root 3 over 2. Okay, so this is root 3 over 2. How about cosine pi over 4? Root 2 over 2. Cosine pi over 3? 1/2. Okay, therefore, you see, pi over 6, which is right here, that's root 3 over 2. And pi over 4,
pi over 4 is in the middle, is half of pi over 2. Right here. So that is this point. This point is
root 2 over 2. Okay, the numbers are decreasing. This is root 2 over 2. And then next, pi over 3. See here? That is 1/2.
For the cosine values, as the angle increases, the y values decreases. Can you see from the picture? Yes? Okay. And also, if you draw the cosine graph, and if I can ask you, like, what is the value of this point? Well, then you can find symmetry. Okay, this point corresponds to be here, right? And so it corresponds to, let's see, this is, it's gonna be 1/2, right, everybody? So we can draw the picture and then we can figure out.
Besides using the reference angle. Okay? All right. Everybody finish this picture? Yes. Okay, now go to the sheets. Now we draw the cosine. Okay, so draw the cosine. The theta in the theta, what are the 5 key points? Good. And what's cosine 0? Yes, very good.
So sine and cosine, they're both waves. But sine start with 0 and cosine start with 1.
So let's plot the points. The 2 pi is here, 0, and the middle is pi. The middle here is pi over 2. The middle here is 3 pi over 2. And we have 1 and minus 1. 0 is what? Pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. 2 pi, is 1. And then we connect them smoothly. So this is the graph of cosine. Cosine, they are wave. Sine start with 0. Cosine start with 1. Everybody okay with that? Good. Okay. So let's keep going. Okay. So we talk about the graph of sine and cosine. Now let's review. Okay. Do you still remember in college algebra we talked about the order of transformation? Yes. We have first shift left or right. Okay. And that is when your x's add or subtract some number. Shift left or right. And the second one is reflex over the y-axis. Then you will see a minus sign in front of the x. And then the third one, reflex over the x-axis. You will see a minus sign in front of the entire function. And then you see vertical stretch, right? It's the y multiplied by some number. And then the last one is shift up or down, the y plus or minus a number. Okay, everybody? So that is the order of transformation. And so let's review. How about now we have the track functions. Okay. If we multiply the y value by a number, then we stretch vertically by a factor of 8. So this is the same thing. You see, this graph is sine 1x. And then when you multiply by 2, do you see it stretched by a factor of 2? Right, everybody? If you multiply by 3, oh, it becomes bigger. Multiply by 4, oh, it becomes bigger. Okay. So amplitude, the graph of a sine x or a cosine x with a not equal to 0 will have the same shape as the graph of the sine or cosine. But because we stretch, our old range was -1 to 1, but because you multiply by a, our new range will be negative absolute value of a to absolute value of a. So our range change. Okay, so the amplitude is the absolute value of the a. Okay, everybody? Therefore, for sine x, what is the amplitude? 4, yeah, exactly. The amplitude is 4. Okay, so that is vertical stretch. Now, horizontal stretch or compress. Okay, so in college algebra, because the function we learned is like x squared, x cubed, so we didn't really go deeper in the horizontal stretch or compress. Because at that time, we were, for example, if we have a horizontal compress for a square function, you can kind of distribute the square. It becomes 2 squared times x squared. So we get 4 times x squared. So in college algebra, the horizontal compress now becomes vertical stretch. That's why we didn't go deeper to the horizontal compress, right? But now we need to talk about that because can you move if we have a bx inside the sign? Can you move the b outside of the sign? No, we cannot do that. So horizontal stretch or compress. If you have the x replaced by b times x, then we have horizontal compress by a factor of b. For example, if this is sine x, okay, the orange is the sine x.
the sine 2x will be compressed by a factor of 2. So our period was 2 pi. Now the new period is pi because it compressed. Okay? And how about sine x over 2? Well, if you have a fraction, that's going to be horizontal stretch. Okay, everybody? Mm-hmm. So, therefore, what's the new period? The new period will be the period of our original trig function, 2 pi, over the coefficient of x in the angle. Okay, everybody? So this is the angle. It's also called the argument. And the new period is 2 pi over the coefficient of x in the angle or argument. Okay, so that's the b. That's the coefficient of x. So that is the horizontal stretch or compress. Okay, next, horizontal translations. So we call from algebra, adding or subtracting a constant to the x will shift the graph left or right. And remember, minus d is shift to the right. And plus d is going to be shift to the left. Okay? So minus right, plus left. So that's why in this picture, the sine x is the blue one and or the purple one. Okay, violet. Okay, and then when you subtract, it's gonna be shift to the right. So the orange one shift to the right, pi over 4 units. Do you see from the picture? And when we minus pi we shift to the right, pi units. Okay, but when you add the number, then you shift to the left. Okay, that's horizontal translation. So the same results apply to the graph of the trig function. We have two new vocabularies. A horizontal translation is called a phase shift. The expression x minus d that you plug into the trig function is called the argument. So the angle is also called the argument. It's the input of the trig function. Okay. All right, and we also have vertical translation. So if you have the entire function plus c, we're gonna shift the whole function up by c units. Right? If subtract c, then shift down by c units. Here, we have the midline. Okay, so this is the midline. Okay, and when you plus c, the midline is gonna shift up by c units. Like here, this is sine x. The midline is the x-axis. Right, everybody? When we add 2, where is the midline? Y equals to 2. Okay, everybody? The midline is going to be y equals to 2. Okay, so how do we graph a trig function? Okay, that is very important. And I'm going to teach you 2 methods. Okay, you can use one of the 2 methods. Method 1. You want to express the function in the general form. So A, that's the amplitude, sine bx minus c plus d. Okay, or is a cosine function. Identify the amplitude, which is the coefficient of the trig function. Okay, that's the absolute value of A. And then identify the period, which is 2 pi over the absolute value of coefficient of x in the angle. Is that clear, everybody? Mm-hmm. And then 4, identify the phase shift. So the phase shift is, in this case, you can factor out the b, okay, like here, you factor out the b, you get x minus c over b. That's why the phase shift, x minus a number, that number is actually c over b. It's not just c. Okay, that's the phase shift, c over b.
not just C. Because if you want to factor out the B, that is the phase shift. All right, and then we draw the graph. A sine bx shift to the right or left by C over B units and up or down by D units. And you follow the order of transformation. So do you still remember in college algebra the order of transformation? You need to draw like each graph for each transformation. And you get a sequence of graph and formula. Okay, so shift left or right. To the left, plus, right, minus, the x becomes plus or minus a number. And then second, you have to follow the order. Otherwise, the transformation might not be the same one. Okay, second one, reflect about the y-axis. You put a minus sign in front of x. Third one, reflect about the x-axis. You put a minus sign in front of the y. Or, and here, step 3, also vertical stretch by a factor of c. So c times 1. And the last one, shift up and down. Okay, so y plus or minus c. This is method 1. Okay, so you look at the order of transformation and draw the graph step by step. And that's method 2. So I would think method 2 is easier. Okay, so method 2, you just need to draw one graph. So method 2, make a table of values with columns x, theta, sine theta, and y. Fill in the theta, sine theta columns first. Then fill in the x and y columns. Plot those 5 key points and connect them smoothly. So that is method 2. So instead of drawing a sequence of transformation, let's do method 2. Okay, so from now on, I just show method 2. Okay, look at this. So method 2 tells us that first we're gonna make a table. So leave some space here. So on the right, we're gonna draw the picture, and then we're gonna make a table on the left. Okay, so leave some space on the right. So the table, we have 4 columns. Okay, so the table, we have 4 columns. All right. The first column are the x values. The second columns are the theta. Theta is the angle. In this case, the angle is what? 1/2, or maybe I just put theta. But you know the angle theta is 1/2 x minus pi. Is that okay, everybody? That's the angle. That's also the argument. And then the third column is the sine theta. And then the last one is the y. The y, look at the picture. Look at the formula. Is 4 minus 2 times sine theta. Write down the table first. The x, theta, sine theta, and the y. The y is 4 minus 2 sine theta. So everybody have this step so far? If you don't print out the worksheet, you have paper. You take a look on the paper. Okay. So step 1, fill in the theta column. How do you fill that in? Look at this. The 5 key points. They are 0, pi over 2, pi, and 3 pi over 2. So remember those 5 key points. So the step 1, fill with the theta column. Step 2, fill with the sine theta column. How do you fill in the sine theta column? 0, 1, 0, -1, 0. Okay, 0, 1, 0, -1, 0. So this theta and sine theta value is going to be fixed. Okay, so that's why I give you this. Once you draw the 5 key points, it's fixed. Okay, so after that, we want to find the x. So step 1, fill with the theta. Step 2, fill with the sine theta. Step 3, fill in the x column. So how do we find the x? Here, theta is 1/2 x minus pi. We want to express x in terms of theta. How do you solve for x? How do you solve for x? What do you do? We want to solve for x. So we want to get rid of the minus pi. How do you get rid of minus pi?
Theta plus pi.
Yes, so theta plus pi is, so both sides at pi, we get 1/2 x. Right? Now what's next?
1/2.
We divided by 1/2 is the same as multiply by 2. Yes? Both sides multiply by 2. Okay, then we have x is 2 theta plus 2 pi. Is that okay, everybody? So we solve for x. All right, so x is 2 theta plus 2 pi. Use this formula. We can fill in the x column. We plug in different theta. Okay, what's this number? We plug in theta is 0. See? Yeah, we had 2 times 0 plus 2 pi is 2 pi. Right, everybody? Okay, we keep going. We have 5 numbers. How about here? We plug in theta is pi over 2. Yeah, so 2 times pi over 2 plus 2 pi. The 2 cancel. Pi plus 2 pi is 3 pi. Yes, everybody? How about next? We plug in theta is pi. So 2 times pi plus 2 pi. What is that? Hmm? 4 pi. Yes. So far, so good, everybody? How about next one? So 2 times 3 pi over 2 plus 2 pi is 5 pi. Good. And then the last one, 2 times 2 pi plus 2 pi is 6 pi. Okay. So that is the x column. Is that clear, everybody? We fill in the theta and sine theta. This is fixed. The 5 key points are fixed. And then you look at the relation between the x and theta, solve for x, plug in the theta numbers to find the x column. Now, here to find the y. So step 4. Okay, make sure you follow the steps. Step 4. You look at the sine theta and you plug in, you find the y. So here, 4 minus 2 times 0, yeah, is 4. Right, everybody? Sine 0 is 0. We plug in sine theta is 0. Next, 4 minus 2 times what? 1 is 2. Good. And then next, 4 minus 2 times 0 is 4. Next, 4 minus 2 times -1 is 6. How about the last one? It's also 4. When you plug
again, you realize 0, 0, 0. So that those three numbers are the same. You actually just need to calculate what 1, 2, 3 numbers. Because three of them are the same. Do you see we get all the x and all the y values? Now we can draw them on the picture. So that's the graph. And the biggest number is 6 pi, right? So you draw the graph, the biggest x is 6 pi. So let's say 6 pi is here. Then you know that's 2 pi, that's 4 pi, and then this is pi, 3 pi, and 5 pi. 1, 2, 3, 4, 5, 6. 6 pi. Is that okay, everybody? Mm-hmm. All right, let's see. When x is 2 pi, what is our y? 4. Okay, so the y value, the biggest is 6. Okay, so let's say with 6 here, and then the 4 is here, the 2 is here. So at 2 pi, we get 4. So put the dots here. 2 pi, we get 4. Right, that's the first row. Everybody get the first row? How about second row? Yeah, 3 pi, we get 2 right here. Next, 4 pi, we get 4. 5 pi, we get 6. And 6 pi, we get 4. Right. So we draw 5 key points. Okay? Now just connect them smoothly. So when you connect them, don't do it like this. They're not like line segments. So connect them smoothly. Is that okay, everybody? In the exam, if I say draw 2 periods, so draw 2 periods, you're gonna copy this and paste right here. Yeah, everybody? So then, okay, you can imagine this is the next point, and then here, and then here, and then here, right? So I usually ask you to draw 2 periods. So you put it here, 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 and here. Then you're gonna draw it like this. Then you draw 2 periods of the graph. Is that clear, everybody? Okay, if I ask you, what is the amplitude? Amplitude is, okay. Amplitude. Amplitude. Okay, amplitude is the coefficient of the sine function, which is 2. Yeah, absolute value. So amplitude is 2. How about the period? What's the period of 2 pi? Sorry. What's the period of sine x? 2 pi. Yes. And we use 2 pi over the coefficient of x. What's coefficient of x? 1/2, right? The coefficient of x is 1/2. That's why we get 4 pi. And you can also see, so our x values is from 2 pi to 6 pi. What is the difference? 6 pi and 2 pi, the difference is 4 pi. So 2 ways to figure out the period. Either use 2 pi over the coefficient of x in the angle, or you can use the difference between those two x values. How about the midline? Yeah, y equals 4. So that is the midline. Midline is not a number, it's a horizontal line. Y equals 4. Okay, everybody?
So this is method 2. Do you think method 2 is easier than method 1? You just need to draw one picture, right? You don't need to do a sequence of transformation. All right. Any questions about this problem? No? All good? Okay. We only have 4 minutes, so I don't have enough time to ask you to fill out the numbers. How about let's do that on Wednesday? Okay? So study the practice exams, and then Wednesday, I'm going to ask you to fill in this chapter 7 blank formula sheets. In the exam, I will give you this blank one. You can spend 1 or 2 minutes. I hope you can fill out all the values in 1 or 2 minutes. Then you can look at the table to work on the exam. Have a nice day. So this week, if you have questions, come to ask me. And if you cannot meet me in my office hours, feel free to email me. We can meet in the evening virtually. So we can all go to the big blue button and meet virtually. Yes. Okay. Bye.